Hello everyone, I'm Karan. Today I'm here to share a quote. Don't take rest after the first victory. If you fail in second, more people lips are waiting to say the first victory was just a luck. The quote was said by the great scientist and the former president of India, Mr. APJ Abdul Kalam. From the quotes, we understood that success is not final, uh, failure is not fatal. Keep on going with the constant hard work and smart work, it will lead to be a successful person in your life. Thank you.
Two-port networks. Suppose we are having a circuit like this. It has two ports. That is two terminals for input and two terminals for output. Then it may be called as two-port network. Two-port network because this is one port to give input. This is another port to get output. Here, the for this we can obtain a mathematical model like this: V1, V2 equal to Z11, Z12, Z21, Z22 multiplied by I1, I2. Like this, we can obtain the mathematical model. Generally, for any circuit, we will obtain the mathematical by using either KVL or KCL. Here, the circuit is represented by V1 equal to Z11 I1 plus Z12 I2. It is the V1 is represented by both the input and output currents, two port currents. Z11 called input impedance with output port opened with output port. That is, there is no voltage across the output port. Output port opened. Z12 is called reverse transfer impedance. Transfer impedance with the input port open. I2 equal to 0. Here I2 equal to 0. Here I1 equal to 0. Similarly, V2 can be represented by Z21 I1 plus Z22 I2, where Z21 is forward transfer impedance, assuming output port open, whereas Z22 is output impedance. Output impedance. Input port is open. Input port is open. Therefore, here I2 equal to 0. Here I1 equal to 0. In this way, we have to find the parameters. So this gives the mathematical representation of given circuit. It may be an amplifier. It may be an amplifier, input and output. It has two terminals, two input terminals and two output terminals. Or it may be a long transmission line. Suppose the long transmission line is looking like this. High voltage transmission line is looking like this. Power is transferred from one place to another place. In our case, it is transferred from Neyveli to Pondicherry. In that case, here two terminals are used to give the input power to this network. Here two terminals are used to get to the power. Here, if the output is open means output, no power is taken here means I2 equal to 0. In that case, we can find Z11 and Z21. What is the impedance across these two terminals? When I2 is 0 means you will get Z11. If you find the relation between V2 output voltage and the input current, then you will get Z21. Similarly, if I2 is there, in that case, I1 equal to 0. Input port is open means we can find Z12 and Z22. In that way, we can represent this network by mathematics so that we can simulate the circuit. We can find the response of the circuit by using these mathematical models. Parameter circuit is represented like this. Represented like this, where Z11 and an dependent source. Similarly, here another dependent source. This is a voltage source. Voltage source, that is Z12, I2, depends upon the output current. This is Z21, I1, depends upon the input current, this voltage, in series with the output impedance, Z22. That's all. V2, this is I2, this is I1. Here you can notice that in both terminals, the current is mentioned as input. That's why, suppose a circuit which has input current and output current means that output current will be represented minus, so that the current is coming out of the circuit. If it is getting into the circuit means positive, coming out of the circuit means negative. That's all. Then what is Z11? Z11 equal to I2 equal to 0. Already we have seen I2 equal to 0 means we will get Z11 equal to V1 by I1. Similarly, Z12 equal to, provided I2 equal to 0, Z12 equal to V1 divided by I2, where I1 equal to 0. Similarly, we can find Z21 equal to V2 divided by I1, provided I2 equal to 0, and Z22 equal to V2 divided by I2 and I1 equal to 0.